let's talk about how to interpret the slope and y-intercept of least squares regression lines. Let's start with the slope. So the definition of slope is rise over run, or you might hear people say change in y, which remember is the response variable, divided by the change in x, which is, remember, the explanatory variable. So if a line had a slope of 4 over 7, that means that if x increases by 7, y also increases, but it only does it by 4. If it were negative, so let's go over here, if slope were negative 4 over 7, that means when x increases by 7, y decreases because it's negative by 4. It's a little bit different though in statistics because the slope is the slope of the least squares regression line. So we do not want to imply that a certain increase in x guarantees a certain increase or decrease in y. So instead we interpret the slope using the words on average. So there are two interpretations of the slope. If the explanatory variable, and we should of course put in whatever the explanatory variable is for whatever problem we're doing. So if the explanatory variable increases by 1 unit, whatever they are, miles, seconds, whatever, the response variable either increases or decreases by whatever the slope is with certain units. And then we would say, there shouldn't be a period here, there should be an on average, and then a period. Or we could say, if the explanatory variable increases by 1, that's exactly the same thing. Okay, ignore that. Clearly I was half asleep when I wrote that. Okay, so the y-intercept of any line is the point where the graph intersects the y-axis, which is the vertical axis. In other words, it's the y value when the x value equals 0. So to interpret the y-intercept, we have to ask two questions first. The first one is 0 a reasonable value for the explanatory variable? Obviously, if the explanatory variable is the weight of a human being, 0 is not a reasonable value. The other question we have to ask is, do any observations near x equals 0 exist in the data set? If the answer to either of those questions is no, then we cannot interpret the y-intercept. The second question is very important because we should never make predictions outside the scope of the model, which in this case means that we should not make predictions for values of the explanatory variable that are much higher or lower than those that were observed in the actual data. So for example, if we go back to our club head speed and golf ball distance, let's interpret the slope and the y-intercept. So just as a reminder, our equation was y hat equals 3.1661x minus 55. Let me go get that number again. 55.7966. Okay, let's interpret the slope first. So for the slope, we would say if the club head speed increases by 1 mile per hour, then on average, the distance the ball travels increases, because it's a positive number, by 3.1661 yards. Okay, let's talk about the y-intercept now. For the y-intercept, we need to go back and look at our data values. So here's the explanatory variable, the club head speed, and we need to know if there are any values there that are close to 0. Well, the smallest club head speed we have is 99 miles per hour, and that is not anywhere close to 0. So we have answered no to question 2 that we have to ask ourselves when we interpret the y-intercept. So for the y-intercept, we should not interpret it. And that is because a club head speed of 0 miles per hour is much lower than any of the observed values. Well, that concludes section 4.2. Congratulations, you have almost made it to the end of the semester. There is only one more exam to go.